What's up, guys? Matt McAdam here, your truck editor at Driving Line. Another episode of Chasing Dust for you today. I am in Riverside, California, and we got an awesome episode for you guys. We're here at Icon Vehicle Dynamics. You guys know who they are. They're a shock company, they're a suspension company. They actually make wheels now too. A lot of really cool products coming out from these guys. I really wanted to see the behind the scenes of what they do here at their manufacturing plant out here in Riverside. So we're out here today. They've agreed to give us a tour. I'm super stoked to check it out. So let's get in there and see what they got going on. What's going on, Dylan?
What's going on, Matt?
Hey, how are you?
I'm doing great.
Thanks for having me come down today.
For sure. Come on in. Let's take a look around. Conference room here. Have the presentation board we can do some stuff on, touch screen and whatnot.
Nice.
We do a lot of engineering reviews and stuff in there.
Yeah, where all the big decisions are made.
Sales department.
Hey, everybody.
How's it going? Howdy. Our marketing team.
What's up, dudes?
How's it going, guys?
You guys are the ones responsible for all the cool posts and content, huh?
Right.
We try, man.
Yeah, you guys do a great job.
But we try to do our best.
This place is huge.
Yeah, we about a year and a half ago we almost doubled the square footage.
Oh wow!
Yeah.
Same building? You guys just took over?
So we on the property there was an extra acre and a half.
Yeah.
That we when we were small we just leased it out to like semi-truck parking.
Right.
So we kicked those guys out and just built another building Siamese to this one.
Oh, that's even better. It's easy.
So where the old roll-up doors were.
Yeah.
For the original building, they're just passageways now.
To go to the new side. Yeah.
The new building.
Awesome.
Yeah.
Got a nice Raptor right there.
Yeah.
Oh, and a Gladiator.
We're going to do a scan of the frame rail here. We have some of the CAD data already, but it's nice to be able to have that scan, and then you can pick whatever points you want.
Yeah.
So we're going to be scanning this here in a few minutes. Shock assembly right here.
Okay.
So we've got a couple different ways that we do it. We do a production line or we do a cell. So depending on the type of shock it is. Some things are better built at one cell with one tech that builds the 90% of it from start to finish with assemblies, and then other things we do on an assembly line.
Like a line, yeah.
Each person does a different stage.
Cool.
You can see some of the parts. These are all cast sub assemblies getting ready to be dropped into cylinders. Looks like a F-150.
Yep, beefy rod ends on them.
Yeah. So these are all now waiting for packaging.
Okay.
So, or to be some of the rest of the kit to be put together with it. So some of them are waiting for like an upper mount or something like that. So also in packaging we're doing assembly of anything that's not a shock. So billet control arms, track bars, where they've got left-right adjusters and Heims and all that gets pressed in here. Yep. All the delta joints for the UCAs get assembled here.
Yeah.
And then also the packaging. So from packaging it goes then through that roll-up door used to be the end of the building.
So that's where you guys added it on? Yeah.
Billet A arms getting ready to get boxed.
It's awesome.
Almost everything is delta joint now.
Yeah.
It was a little bit of a educational process to get people
away from the Uniball.
The Uniball was such a buzzword.
Right.
It took a little bit of time, but it was actually I was apprehensive, but people actually embraced it way more than I thought, and it's been great.
Can you give us a little bit of a idea of what makes it different from a Uniball and why you guys are starting to use them more?
So the Uniball is originally the part that we buy, the Uniball itself is an industrial component. It's meant for machinery and things like that. Then what the off-road industry did is they took it and they did high misalignment spacers to get way more angle than it was supposed to.
Right.
So originally they were meant to be in some machine and it only had 12 degrees of misalignment, but we want 40.
So a really short travel path.
Right, short travel path. And so then we do these misalignment spacers and adapters that get a lot of angle. The other thing they weren't meant for was certain environments. So because they're industrial, a lot of them are in factories inside. They don't handle any place where they put any salt or black chloride on the road. They completely disintegrate in a short period of time. So, but the angularity was cool, and the fact that You can press them into a fabricated part or a billet part. Early on, they were easy for us to adapt.
Right.
So we found a cool part, extended its travel range, and then was easily adaptable to something.
Yeah.
So what we did is we took the two things that we want. We want it easily adaptable. That means it's got a common bore that presses into cups,
whatever you want,
into your Uniball cup or whatever you're dealing with.
Yep.
So we need that, and we also need a lot of travel. But then we need to solve the stuff that is a problem, which is the environmental and noise.
They squeak a lot.
Squeaky.
Oh yeah.
So what we did is we made a hybrid. It's got the housing of a Uniball. It's got the high angularity of a Uniball.
Yep.
But it's got the other aspects of a ball joint. So it's a one-piece stud, ball, grease grooves, greasable. It's got a special seal that we developed for it because a boot, a conventional ball joint boot, isn't going to handle 44 degrees of angularity. It's just not going to do it.
They tear very easily.
So what we did is we made a seal that's more like a wiper seal. That sweeps the ball and sweeps the dirt out.
Got it.
And that seal also allows, when you re-grease it, allows that grease to purge out. So it will purge the old grease whenever you
holds the new grease.
So it's got a lot of the benefits of a ball joint. Greasability, quiet, less friction. That's a big one. You get a really tight Uniball and your steering sticks. So you go, when you're trying to go straight on the freeway, it'll stick a little left and a little right. And you're constantly doing this because of friction. Friction throughout all suspension systems is a big deal for ride quality. So we've got the friction down, no noise, serviceable, but the benefits of pressing into a cup and high angularity.
So are they also replaceable, or are they?
Yeah, absolutely.
So you can just press them out and press them in like a regular Uniball?
Absolutely.
That's awesome. Yeah.
But the other big one is warranty. So we were confident enough in the lifespan of them that we gave them a long warranty.
Yeah, so you don't have to worry about it.
Yeah.
That's
and
really
Uniball warranties are like, those are wearable items. You're not going to get a lot of life. If you live in the snow, we can't really do much about it. But we can. With this, we can stand behind a really good warranty.
And did you guys develop that here?
Yeah.
Or was that's awesome. Yeah.
So on the bottom, it's retained out here with the same spiral lock ring that retains a Uniball.
Yeah.
If you look really close, you can kind of see there's a rubber wiper right here where my finger is, and that's it's like an eyelid kind of, and it sweeps the ball and keeps all the contaminants out. And then you can see the grease grooves, and then on the top side there's a low profile grease fitting, and then when you do the installation there's a cover cap. And the cover cap on here just seals it off and makes it look better and finishes it off nicely.
That's really cool. So you just pop that off, grease it, purge the old grease out of this seal right here.
So
that's good to go.
When we have half a dozen different Uniballs, half a dozen different delta joints, the outer housing and all of this is the same on all of them. The only difference is what stem they're for. Whether it's for a Toyota or a Ford and what a Chevy, whatever that taper may be.
Us off-roaders, we're pretty I guess stubborn when it comes to a part that we've used for a long time, and it's just really hard for us to accept the fact that there may be a better way to do things. But you know, oftentimes the case is that there is a better way to do it. You just gotta explore it.
Oh, there's always a better way. It's evolution. So we gotta stay with it, and we've got a bunch of other little irons in the fire for trying to keep up with times and make some progress in technology.
Stay on top of things. One of the things that's always, and just for your, I don't know if you knew this, but the first suspension system I ever put on a truck was an Icon stage, I think it was a stage 2 coilover kit on my second gen Tacoma. It was one of the first trucks I ever built. And I just love the fact that you can get all the components necessary to build your suspension from one company versus having to go to different shock companies, find the coilover you might need, the upper arm you're going to need, the leaf pack you're going to need. So it's just, that's what sets you guys apart from everybody else.
That's what we call it holistic engineering. So if there's a problem or a limitation to extract more performance, then we have to address it. So if that means that we now need to make an A-arm where we didn't before, or we need to make a bracket or whatever it is, we can do all those parts. We're not
You're solving for each one of these problems.
And you know what's really nice for the end user is if you've got 4 different manufacturers on your vehicle and you have a problem, well, who's going to deal with it?
Who's going to tell
and
you
every
what to
company
do?
is to say, well, it's not my part.
Right.
So it's really nice for the end user to have one company to go to.
Yeah.
And we have more confidence that it's all going to work together.
Right.
Because we designed
You
it all
engineered it to
together.
work together. Yeah, exactly.
And that's kind of how the wheels started. So we had a recommendation for wheels offset to get the size tire that you wanted.
Yeah.
And we're like, well, we recommend this offset. Well, there's only this wheel or that wheel or whatever. And that way we can say, hey, if you really want this size tire, we've designed this wheel with the correct offsets and clearances to fit the maximum tire. The Tundra is a great example. Yeah. So the Tundra, there was very little 17 availability because the brakes are so big. Yep. And then there's a sweet spot of where that wheel sits to have enough width to get your bigger off-road tire, but not so much that you start running into the fenders.
Yeah, so rubbing into everything.
So we made a wheel that's clean, travel with a 35 and fits the.
So that's where the wheel idea was born, just out of solving
out of necessity.
That issue.
Yeah, it's all out of necessity.
Awesome, man. Yeah.
These are all weldments that have been powder coated, waiting to get kitted. So packaging will pull whatever weldment it is from here to make whatever kit. There's all various rod ends, all kinds of stuff.
Yeah, I got some reservoir hoses here.
Hose assemblies. We build all the hose assemblies over there.
Yeah.
So we build all the hose assemblies here.
So you guys just get a big reel of hose and you guys actually put it all here in house.
Yeah, we've got the crimping machines and all the various fittings, and we can put together whatever hose configuration.
Very cool.
We've got 2 robotic welders.
Oh, so there's not people in there doing that.
No, those are robots.
Yeah.
This was the first one we got. We named it Johnny 5. I don't know that we've named this one yet.
Yeah.
Robotic welding added a lot of capacity.
Oh yeah.
So we still, I would say, do at least 50% with manual welders.
Humans,
Yeah, humans. A lot of the parts are complicated, and you really you want that human to make sure everything's right. And their weld quality is great. The robot is programmable to be pretty much as good as a human.
Yeah.
So we've been pretty happy with that.
That's fascinating, but at the same time a little bit creepy.
Right? Yeah, the welding robots, that's not really that new. I mean,
no, I know.
They've been doing that for a long time.
I don't think I've ever been up next to one up close, so it's really
this one
interesting.
is trap bars.
Yeah.
So the way both these work is that we'll walk around to the back of the machine.
Okay.
So there's a wall right here in the middle of the machine that flips 180 degrees.
Oh,
so
okay.
you operate it from the back.
I see. Yeah. Got to have a little bit of a human element to it, right?
Yeah. Yeah, the machines aren't really as smart as people think. They only do what you tell them to do. So
Yeah, they're only smart.
You gotta have smart people telling them what to do.
Right, exactly.
Come here and let's see where we want to start. We hit the trigger. It projects some laser lines Let me, and then if you look at the screen,
that is unreal, man.
isn't it?
Wow. See, it's mapping out the whole frame here. There's the body mount right there. Some of the body up there.
And you can see the laser lines being projected on the part.
Yeah.
This light on the back tells me if I'm too close or too far away. So
Okay.
if I'm red,
Red's
I'm too close.
Green's good.
But I just hold it in my hand.
You just kind of sweep over the frame.
And there's the muffler.
Yeah.
Go off the bottom of the frame. I come in here and scan it.
So about how wide of an area can you scan? Do you just do the whole car or?
14 feet.
Wow.
Actually, it says 14 feet without that accuracy, but you can go bigger.
As long as you
So as long as you have enough dots so that it can remember where it was
Everything else,
as you move, you can do the whole side of the car.
That's incredible.
Yeah.
I mean, the amount of time that it used to take to do something like this back in the day.
And then I can go in here and zoom in and move it around.
You have
And
a
then-
3D model.
Yeah, and then a 3D model. You know, and that was what, 1 minute.
Yeah. You did like a 3 foot
Now when I
section of the frame.
complete this scan later today, I'll go over here and I'll get a more complete scan and I'll focus in on some of the holes and
Right.
the more you wave it over the surface, the more
Information it gets,
it
yeah.
increases the accuracy. It's
Right.
always adjusting the cloud of data to be more and more accurate. So if it sees the same thing 10 times, it'll keep on making it better and better
Yeah.
as you wave it back and
Reaffirms
forth.
that it was right
Yeah.
and all that. Yeah. So
But-
you guys will take a frame scan like this and then design your products onto it.
Yeah.
Are you able to also like articulate the suspension in 3D as well? And
Yeah, so that's what we would do with our parts.
Yeah.
So once we put our parts in there, then we run them through the range of travel and everything.
and see where you could even see maybe your tires rubbing or something,
Yeah,
even in 3D before you actually put it on the car.
Yeah. Everything obviously gets validated in
Real life,
in the real world.
Right.
And that's a pretty fun part of the job as well.
Yeah, yeah,
We can make a part more accurately. So we used to make a prototype part,
yeah.
put it on the vehicle and say, well, let's move this hole over a 1/4 of an inch here and up a little bit, change angle. And it was an iterative process. And now we can nail it first time out.
So I've seen this machine before, but a lot of you guys probably haven't. This is what's called a shock dyno, is that right?
Yeah.
Yeah.
So on the screen here, it's showing the shock compressing through the compression and then coming back to the center and then rebound and then back up. So this shock shaft speed is going to be quartering, maybe, you know, a little pitch, braking pitch, acceleration pitch, medium cornering pitch. That's about the shaft speed for that.
Got it.
A lot of the tuning here, and you can see the shape of this graph is building a lot of force quickly at that speed.
Yep.
But then as we speed it up, it's going to change because of the digressive piston.
Right.
Let's see where it starts to change here. So you can see here as I'm speeding up, now it's making a lot of force at low speed, but as it gets faster and faster, you don't want to overdo it. So it starts rolling off.
Right.
So it curves down and then it starts curving the other way again.
I see that, yeah.
10 inches per second is still not a really fast shaft speed. Going over the railroad tracks is going to be about 50. I'll show you what that looks like. So railroad tracks is going to be something like this.
Oh, wow.
And then we can go a little faster. this is a cold shock. Now put your hand on that.
Oh yeah, yeah. That's too hot to hold your hand on it. Now.
Right. You can. It's about a two second touch, and that's it. That's the amount of energy that I can pound into the shock.
Right.
For durability testing and so it more than equates to off road.
Oh yeah.
Where the anomalies that you have to then correlate to real world are the super sharp spikes, which are
big bumps.
Which are short and instantaneous, so they don't really put as much heat in, but it can harm some internals. So like clipping a curb at 40 miles an hour.
Right.
You know, at that point, you're probably breaking stuff.
Some internals.
And then we can watch the screen as we start adjusting up the compression. So this is our compression curve, and we want it nice and soft. It's on the softest setting. And then as we start turning the knob up, each click of the knob is another higher setting.
It gets a little steeper.
Yeah. So you can see our range of adjustment. So on the softest setting at this speed, 25 inches a second, we're doing 200 pounds of force, but we can go up to 450. So we've got a really dynamic range as a percentage of the base. So some external adjusters, you've got, a 15-20% range. So it's really just kind of fine tuning. It's not gonna change the reaction in a major way.
You may not feel it.
We calibrate everything so that you can really get something useful out of it.
Right.
If you've got more weight in the back, or you're just driving more aggressively. So that's the main thing. It's more, we use it mostly for just the level of aggression that you're driving.
Yeah, that makes sense. And everyone's got a different driving style, so that valve can definitely help you fine tune whatever fits best for what kind of driving you do. Yeah.
And then we've got different internals depending on whether it's IFS. It's calibrated a certain way, and then it's calibrated differently if it's a 1-inch shaft on a 3.0.
Yeah.
So all those different situations have a different internal calibration for the CDC itself.
Yeah. So it's not like a one-size-fits-all valve.
So it's appropriate for the application.
Very cool. Yeah. So it's nice and cool in here in your meeting room.
Yeah, much nicer.
Yeah. You guys do a lot of testing on your vehicles before you guys actually release a product. So can you give me a little insight as to like what you guys do and what you're looking for, and if there's any changes you guys have to make, just go through that process real quick for me?
Sure. So twofold with the testing is durability. That's a big concern, and then also performance. So when we're going out, we're doing durability on the components and tune revisions on the suspension to get everything working well.
So you guys actually making changes on the fly out there too?
Sometimes, we'll do that on the bypasses and the compression adjustable shocks. What we'll do is we'll bump up some of those settings, and if we get too far towards the stiff or the soft end of the range, then we'll come back retune the internals and go back out with a different base, and then we can reset all the external adjusters and stuff like that.
Nice.
The other thing is the durability. So the durability is a big one because we always talk to people when we're talking to enthusiasts. We ask, well, what percentage off-road do you think you do? Is this primarily an off-road vehicle or primarily a daily driver? And they say, most people say both. And when you ask them what percentage is off-road, they'll say, oh, like 10 or 15%.
Yeah.
I don't think most people realize how many miles that really is. So if you've got 20,000 miles on your vehicle and you said 10% off-road, that's a lot. That's 2,000
miles, yeah.
I don't think most people put 2,000 miles on their vehicle off-road, hard off-road, as long as they have them. So, our 1,000 miles that we do over the course of a couple weeks is probably around 5 years for our average customer of off-road miles.
Are there any other race applications you guys are dabbling in, or?
Yeah, next weekend, 2 weekends from now, I'm flying out to Crandon.
Okay.
We support Jeremy McGrath and Brock Hager.
Yeah.
I was out 2 days ago testing with Jeremy.
Awesome.
Getting them set up for some changes in the short course stuff.
Is that like Pro 2, Pro 4?
Pro 2, Pro Light.
Okay. Yeah. Those are some fast trucks. Yeah.
So we were out Monday. Testing the Pro 2. So a lot's learned from that.
Yeah,
That's
absolutely.
Great development.
Yeah, and you guys got Tom Wayas,
and of course Tom,
for Ultra
and
4.
Tom's family. He does all kinds of stuff. He goes to events with us, and he'll be down here next week to hang out for a little bit.
That's very cool. Tom was like one of my original Ultra 4 heroes when I was a kid, watching him racing back in the day, and still now he just seems to just not care and just get ahead of everybody.
And just going wheeling with him is a great time. We did last year. He and I did Rubicon, and I swear he knows where every single rock on that whole trail is. Well, on this particular rock that used to be up there, but it rolled down 2 years ago.
He knows the history behind each one of them.
You want to go here, and then I'm like, okay, great. Great. We had a blast.
He has a relationship with the land.
Oh yeah, for sure.
Yeah, very cool.
Yeah.
Pretty much covered A to Z, you guys' operation here.
Yeah.
That was a really great tour.
By.
So, Dylan, thank you very much. I appreciate you bringing us down here.
Thanks for coming by.
And can't wait to get out there with you guys and do some more wheeling.
All right, sounds
awesome.
good.
Thanks, buddy.
Thanks.
Yeah.